Okay, thank you very much. I'm Ashebir from Jimma University. My research topic focuses on quantifying potential yield and the yield gaps of soybean using the CROPGRO model in the humid tropics of southwest Ethiopia. Currently, soybean production in Ethiopia is growing rapidly to meet the demand for edible oil, nutritious food, and high protein animal feed. Between 2011 and 2020, soybean production increased by 95%. At the same time, the cropland allotted for soybean also increased by the same percentage. The major soybean growing areas in Ethiopia are in northwest, south, and the southwest regions. And in Jimma, that's part of southwest Ethiopia, soybean is largely cultivated by small-scale subsistence farmers under low input and rainfall condition. As a result, the average productivity is much lower than what the agroecological condition of the region is expected to offer. The productivity of soybean are known to be constrained by so many factors, and like the physical factors, the management, and the socio-economic factors. And previous studies have addressed this problem through varietal improvements. However, none have studied the yield gap and the extent to which those factors cause yield gap on this crop. Therefore, quantifying yield gap and the main causes can help to identify possible solutions to reduce the gap and to enhance the productivity of soybean in this production area. The potential outcome of this study was to improve the practice of the farmers by showing suitable practices or strategies that help us to increase soybean productivity. In this regard, the model, which is known as the CROPGRO model, is an important tool to assess the potential yield of soybean and to understand the existing yield gap. Taking this rationale into account, the study was aimed to evaluate the performance of the CROPGRO model and to quantify the potential yield, water limited yield, and the yield gaps of soybean in the target area. Coming to the methodology part, the model was calibrated to determine the genetic coefficients of two soybean varieties using data collected during the main cropping season of 2019 at Malco and Dintu. These are the sites where the research was conducted. The model was evaluated using data collected from independent experiments that was conducted in 2020 at El Darling and the soybean trial data of 2015 and 2016.
Ashebir, can I interrupt you for 1 second, please?
What?
Could you please try to move the slides as you're going through? We're having some people writing in the comments that they want to see your slides, and we're just seeing slide number 6 the whole time.
Okay.
Thank you. Sorry for interrupting.
Shall I move on or shall I move on?
Please continue moving on, but we'd love to see your slides. If you could move them at the same time, that would be wonderful.
Okay. So for yield gap analysis, model simulation were conducted on the dominantly growing variety clubs and the different management options. These were the 5 planting dates and the 3 row spacing dates. The actual yield was obtained by averaging 4 districts' annual production data from 2014 to 2018 and the survey data collected at the end of 2019. Coming to the result part, the genetic coefficients for both varieties were derived through manual iteration and using the GeneCalc tool, and these parameters were presented here. These were the genetic coefficients or the parameters that were derived using the manual iteration and gene tool, evaluations from report dry weights of both varieties for June 20 and July 7, 2020. Planting data agreed reasonably well with observed values. As you can see from the figure below, the data for above ground biomass and the hot dry weights are much closer to the simulated value. This indicates the robustness of the model. Yield gap analysis. The average actual yield was 1.7 ton per acre, that is 58 and 54%, less than the potential yield and the water limited yield, respectively. The yield gap due to water limit ranged from 2% to 6%, whereas the yield gap percentage due to non-adoption of improved crop management practice ranged from 18 to 57%. The findings of this study indicated that poor distribution of rainfall and low night temperature during reproductive stages of the crop due to delayed planting and suboptimal use of row spacing were the major causes of large yield gap percentage in the target area. Conclusion, our study showed that the lowest yield gap percentage was found from May 2022 and June 17 data. Therefore, the model simulation suggested that adopting planting dates, early planting dates is an essential to increase soybean productivity under rain-fed conditions in the southwestern Ethiopia. In conclusion, the soybean model can be a useful tool for quantifying the potential yield and the yield gaps. However, to be able to determine the yield gap and the related causes in tons and the long-term potential yield should be estimated for soybean. Thank you, I finished.
Okay, do we have any questions for Ashebir? Thank you so much, Ashebir. Do we have anyone who would like to, maybe time for one quick question from the audience? I'm happy to ask you a question, Ashebir.
Yeah.
Okay.
Can I?
Okay, continue.
Okay, I'm curious. You mentioned that soybeans are mostly grown by small scale subsistence farmers
Yes.
in Ethiopia. How are they being used